All right, let's go over your last problem set of the semester. Don't panic. I have opened the instructions here. We'll also take a look at CS50s. Mine do not necessarily follow that output, but they do follow the overall problem set. And then we'll look over at my code space. So in this case, you have gained access to the company's SQLite database. Now, SQLite, just to let you know, is not actually used in the way that it's shown here because it doesn't have as much security, but it's fine. Just, I say that because I would never want you to be in a position that says, hey, let's use SQLite for this, right? But really, your goal is to simulate a stealthy intrusion by completing 3 required actions, and we'll talk about those in a minute. And you decide the order, okay? In whatever order you decide. That's a key because it will list them in a particular order, but that's not telling you how to do them in the order here. So I believe this is just a duplicate. So let's actually first talk about this. So the required actions, right? So before you begin, understand your final SQL must accomplish the following. Now, on attendance, I've already planned for you to get some experience with how this database schema works. But for here, let's go ahead and go over what you need to do. So you need to alter the password of the website administrator, okay, to be oops, okay? And in this case, you have to make it an MD5. And this is a really actually real world thing. You don't actually store in a database the actual in the clear password. You do it as a hashed password. And so on the CS50 site, they actually give you, if you scroll down, a link to a CS50 or a link here to where you could type this in and get a actual MD5, okay, a hashed password. So it'll take the password and it'll hash it. Now, really what this means, and I suspect many students taking CS50 would have actually set up a dev environment for coding and actually done this in a coding experience. But for our class, it doesn't need that. Really what you want to do though, and this is what part of what I will grade, is was the password in MD5 hashed? And actually, I'll give you a heads up here, is that this is the only hard-coded only hard-coded value you should be using in the database, and I'll come back around as we get closer to talk about what that means. And basically, it means actually copying and pasting it into your query, okay? So that's one of the actions required. Erase any logs of the password change recorded in the database, okay? So now what this means, and we're going to see this when we look at the schema, is that there's a trigger that when the password is changed on the user table, there actually is a log recorded, okay? So in that case, you're going to have to erase the fact that the user had an updated password. And really what you're doing here, and this is what CS50 will talk a little more about, is the idea that you're a penetration tester. So this is actually a real part of cybersecurity, that what you do is you're hired by a company to come in and see how vulnerable their systems are. And so they often, and I've heard many stories of this, where people who are penetration testers actually physically sneak in to get access. First, can they physically get in? Then can they digitally, meaning can they access the system for vulnerabilities? So, and in this case, you've hired by a small enterprise, and you actually want to show off how well you can actually do this, okay? So I'm going over these requirements right now, okay? All right, so then you're going to add, now, and I say then, but again, part of this is understanding how the triggers work and how you would do this, but you will also add some false data to throw others off the trail. In particular, you're going to frame Emily, make it appear in the user logs as if the admin account had its password changed to Emily's password. Okay, so it's actually telling you some false data here to add. And this reiterates what I said before, which is that, you determine the order to accomplish this. And the way you do this is based on, and by the way, I'm just going to tell you this, there's not one right answer here. There's actually several approaches. The more creative you get here, I expect to see definitely a variety of approaches. Okay. So, and in this case, it kind of reiterates, but like, how do you know your approach is valid? Well, it's a valid if when you look in the user table, right, it shows a new password. There's no visible evidence in the log that of how the password had been changed, and there's at least one misleading log that confused the investigators. Okay. So again, this is what I just said. There are many ways to meet these conditions. What matters is what the data shows and not the specific path you took to get there. Now, this is what I was referring to with the password, is that because we're going to go out and get the password from our hash it, that's the only one that you would actually hard code. Now, hard code in this case, and I'll give you an example. I'll move over to the code space right now, and we'll come back and look at this in a minute. But if you were hard coding like the record ID, instead of actually writing queries that would update things, that would be examples of hard coding, right? If you were, if you were targeting Emily by the ID and not by a query that dynamically looks for Emily's or the admin's information in there, those are examples of hard coding the data. Okay, so just know that that's what I'll be looking for in the output as well. Now, in this case, this is just a setup, right? So let me just go show you because I already have this done. So in this case, right, it's PS3, then don't panic. So remember, it's important that you do this the way I've shown. That way you get all the points possible. And what we're going to do is in the instruction, I've given you the schema, and and I have you create a reset.sql. So now what this is going to do, and this you'll use this several times because as you work through the problem set, what you're going to do is try different things, right? And so what you want to do is get the data back to its original state and then see if your steps, if you're actually taking the required steps correctly, okay? Now what we can see here is we have tables, right? So we have a user table, we have user logs, we have items, and we have orders. Now items and orders are really just, giving you the idea that this is a user website. Somebody comes in and orders things, but what we're most concerned about is the actual user and the user logs, not the items and the orders, okay? But it's good to understand the structure regardless. But the key to this is what I had kind of foreshadowed when we were doing the writing, was actually understanding how the triggers work, right? So I think in attendance, I'm going to have you actually play with each of these, even though we don't need understand all of them for the problem set, is just to actually know what happens when you do and know how to reset the actual database. So you have already by now gotten that experience, okay? So what we can see is like a trigger for the user log user updates, right? So after each update of the username and password on the users, then for each row we do this, right? And this should look familiar because this is what we've been writing. Okay, and then at the bottom, so again, those are the triggers, and then here are the values that get populated, okay? And at the end, and those are the orders, so we're not, again, as concerned about those, but at the end, it actually does do an update, right? So it does show you an example of an update, and you'll see this in the file itself when you're looking at the user logs to give you that idea. Okay, so let's come back over here. So that reset file, right? Create your subdirectory in there, create that. I've given you the schema here, so you copy this into that schema file, all right? You create a hack.sql, hack-q.sql. From previous one, you update the proof of work to be hack.txt, okay? And then what you'll do is create a README file. So now what you're going to do now is in your README file is to create a heading with called My Plan and review the data and specifically the triggers in the SQL, in the reset SQL, and then describe your plan to accomplish the required actions, okay? The order of each does not have to follow. Again, I'm reiterating what we said before, right? Now, in this case, it's like you create a plan, and then when you go to actually implement the plan, there is a good chance, matter of fact, I would expect to see that would change over time, okay? It may not, but I would expect to see that. If you change your plan, add new sections or notes. Don't update here, right? In this case. And this is what I was saying. Don't delete earlier versions. Use pound for markdown, my first update to the plan, and so on, so I can see your thought process over time. And so here I'm just showing you how to initialize. We've done this before, but running SQLite in that don't panic directory and then doing .read will populate it based on the schema. Okay? All right, so now what I want to see, which is different than what the CS50's requirements are, is actually to, and this is the required as far as a documentation. I'll show you an example in a minute in my code space, but what you want to do is which required action are you taking, right? So you do a print, the content for the section required action you will attempt, like what are you doing here? The data before you attempt it. So this is where you're going to write queries to show the data before the required action is taken. So this is actually a very common thing that when you're writing queries, especially in most contexts, but like here's the data before I changed it. Now, here's the queries I'm writing, right? So then in this case it's a print, but this would obviously be where you would actually have the queries that accomplish the required action, queries complete, and then the data after it. So what you would do, and I'll show you again in my example in a minute, what this would look like, okay? But I'm just giving you for each of your required actions. Now, there definitely could be more than one query in here. I would kind of expect to see that for your particular approach, okay? Now, we'll cover this in a minute, but let's just go look over here because I want to show you, here's my proof of work file, and I'm just giving you a new example, right? Now, again, keep in mind, I've said this 3 times now, this is not necessary. You don't have to follow the order. It's really about understanding what you need to do. So this is, the required that's going to action. Like I'm going to update the password to be oops. Now, in this case, I need to actually go find the MD5, copy the password into that website to get that formatted password. I'm not even showing you here because you need to go do that. So in this case, we're going to show the user table, show the data in the user table and the user logs for admin before the SQL. Okay, so before we're writing the update. So here we have admin, and so now once we make the update to the user, we have an insert for admin, and here's the new password. Okay, now this was actually when the admin was set up. And so now after the query to update the user password, I would now see in the user table that new password, and I would see an entry in the log file for, okay, here was the old password and here's my new updated password. So when you're working through this, I expect to see on each action this type of documentation, okay? Because it really helps somebody else looking at your code see if you accomplished the right action required, okay? So let's come back over here. Okay, so now that I've shown you, I've told you what you need to do, I've shown you an example, this kind of reiterates the idea here, but step-by-step development is complete, each requirement one at a time. After each step, document in your README under the appropriate part of your plan. So it's like, here's what I planned on doing, maybe it worked, maybe it didn't, here's what I did, okay? Add your queries to your hack.xq hack-q.sql and output to your hack text. So this is, in a sense, your proof of work is here. Like here's what I attempted, and then reset the database before starting the next step. If you require that. And I probably would expect to see that reset happen a couple of times. Now, because you can follow a different pathway, right? I'm giving you suggested commits here, right? So, I got to update that. So, required action one complete, and so on and so forth. So, as I'm not telling you specifically, I'm giving you, depending on the way you work through the problem set. Okay. Now, once you have completed, let's say you actually got and you looked at, you have now this wonderful hat.text that actually shows the output. I see how many times you went through it, how your work progress goes. Then what you will do, once you have it all complete, you have all three actions ready, then you'll for sure reset that database, uncomment all the print and the SQL command, SQL in the hack.xql. And what I mean by that is maybe what you did is up here, you commented out before you went to try on the next step. But once you get all the way through, because I want one file that just shows me your output, then what you will do is change your output to hack-final text and then run your proof of work. Okay, so what I should see is two proof of work files. I should see the one that you used as you work through each step, and as and commit messages as you change your plan or you implement the plan, and then the final one. Okay, so ultimately I would want to see this one as your final one. Okay, so your commit history for don't panic, your hack xql and the hack.text showing each action. No hard-coded data and actions are taken successfully. Of course, this is a big part of the score. And then output saved to the final. I expect, because this is really where I do these two combined is how I would score this. And then your README file involves evolving strategy with clear structure. Okay, so prove your skills, show your logic. Most importantly, don't panic, because this is a really good, in my opinion, way to end the semester. Because this is actually probably of all the data sets we've done, to me, the most real world in this case. And the way I've set it up is I've tried to give you those skills to help show that. Okay, all right. So I hope this helps you out. I will now go do attendance to give you some fun playing with those triggers and that data. All right, talk to you later.